So here's a kinematics problem where we're told that the acceleration is constant, meaning that this is a problem where we will be allowed to use one of our equations for constant acceleration. To the left, I've written out the three big equations that we want to use in problems like this. Remember that in these types of problems, we want to make a note of the equations that we have, and the variables we have, and whichever variable we're trying to find, and we'll choose the equation that contains all of those variables. We don't want to pick an equation that has in any variables we don't care about, or too many variables that we don't know, or else the equation won't be helpful to us. So for this problem, if we assume the plane starts at rest, then v0, the initial speed, is 0. The final speed, the speed that it has to reach before it can take off, is given as 35 meters per second. And the acceleration, a, is given as 3 meters per second squared. And the thing that the problem is asking for is the length of the runway. So in other words, the distance needed to be traveling at this acceleration. So delta x is our unknown. So we'll want to pick the equation that has all four of these variables. And the only one that does is the v squared equation. So we're going to take that equation and rewrite it to solve for delta x. So first things first, we'll subtract v naught squared from both sides of the equation. So v squared minus v naught squared equals 2a delta x. And then to solve for delta x, we divide both sides of the equation by 2a. So delta x equals v squared minus v naught squared divided by 2a. And really, that's the equation. So let's just plug in the variables that we know. So delta x is equal to v squared, so the initial speed squared, so that's 35 meters per second, and that's squared, minus the square of the initial speed, which is 0, all divided by 2 times the acceleration. So 2 multiplied by 3 meters per second squared. And if we put that into a calculator, then we find a runway length, we find a change in distance, or a change in position, of 204.2 meters, which looks like the book rounds to about 2 times 10 to the power of 2 meters. So that is the answer to this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. And if you have a request or a question, leave a comment down below. Anyways, I hope you all have a lovely day, and yeah, bye-bye.